Delighted to welcome to the stage next Jay Kreps. Jay is one of the co-creators of Apache Kafka. That's been a piece of infrastructure that's been at the heart of the revolution in software architecture that's been unfolding over the last decade, kind of at the center of what real-time analytics is about. He's co-founder and CEO of Confluent, and he's going to talk to us today about really where he sees the streaming world going. There's some compelling thoughts in here. Jay, welcome to the stage.
I think this will fit in pretty well with what we just heard. It ultimately is going to come down to this big, ugly picture here. This is kind of the big, ugly data mess that we all face. And this was actually one of the key motivations for the creation of Kafka. It was one of the key motivations for the creation of Confluent. And I think we've all lived to some degree in this world, which is about all the different applications and data stores and their little pile of data. And how does that plumb through the organization and get to where it needs to go? And each new product or each new trend in the world of data is usually adding to that. It's adding some new point-to-point connections, some kind of brittle, piping between this area and that. And that's true whether it's the next iteration of our customer experience or the new projects around AI. And overall, this data mess, it's not just an ugly developer picture. It's not just like, the architecture doesn't look clean on our wiki. It actually comes with a lot of pain. Each one of these lines is something that's always breaking, something that's always incorrect, something we have to reason about in a very custom way. And you would think an industry that's been around as long as ours would have solved this problem, but it's actually been harder than we thought. A lot of the thinking about data has ultimately been about the storage, not really about the flow. But there has been good thought on this topic, and I think a lot of that is around the rise of data products. And this was mentioned briefly earlier. The idea of data products is, hey, instead of each user of data going and scraping the data that they need from the right source system and trying to clean it up and get it into usable shape, what if we tried to do this a little differently? What if we made it a contract where the person who was producing the data would structure it in a way that was usable for multiple users and present some kind of almost API for using that and produce that in a way that is kept up to date and has a kind of contract of reliability with the rest of the organization. And this is actually a very different way of thinking. In a sense, it's very obvious. If you looked at a big organization and you're like, hey, we got to get data around to a lot of different systems. Like ultimately, all the parts of a business have to be connected and work together in real time in a coherent fashion. You would probably come up with the same answer. You'd be like, yeah, we're not going to be able to have each application scrape data out of every other system as it needs it and maintain that. It's going to be totally unmaintainable. But it hasn't been as easy as just kind of waving a magic wand. Like having a term or a trend, it doesn't really just magically solve the problem. You can't kind of just sprinkle a little bit of data product, pixie dust, on top of what you've got and fix it. And I think there's some reasons for this. One of the biggest reasons is if you look at the world today, it's not just one mess, it's actually kind of two. Broadly, the world of data evolved around these very distinct estates where you have a set of operational systems that run the business, the kind of data stores that do the quick lookups and serve the interactive customer experiences. And then you have a set of analytical systems, which are kind of the deep analysis. You fill it up at the end of the day, you run your big batch job. This is kind of classically the way that organizations built. It's also the way that they staffed things. Often teams are very distinctly placed in one of these two areas. And the movement around data products really grew up on the right-hand side of this. It grew up in this more batch-driven analytical world of, hey, we're going to dump a bunch of data in the data lake. Somebody's going to clean it up and turn it into a data product. Everybody else can use it. And so the question is, does that really solve the problem? And I think the answer is no, not really. At the end of the day, that solves some problems for the users of that data lake. But a lot of the rest of the business is a much more real-time operational system. And so kind of going into the data lake and getting some nice cleaned up data from yesterday is not really going to power that new application. That's not going to be coherent or consistent with the rest of the systems. And I think this is part of a larger trend that's happening, which is the breakdown of the barrier between these two areas. Although we thought about analytics and operational systems as very distinct and kind of never the twain should meet, and maybe the data flow would just be from the left to the right, I think increasingly in the world that's not really the case. And that's true in terms of the types of applications we're building now. When we think about AI applications, which side do they belong on? Are they analytical? You would probably say, yeah, they share a lot of characteristics. They're very data rich. The types of people who might be involved might have a background in that. Yeah, certainly belongs on the right-hand side. But then you would say, well, okay, or are they operational? They're serving customers, whether external or internal. They have uptime SLAs. They have to be fresh and in sync with the data about the business. So clearly, it's some kind of operational application. And the answer is it's kind of both, depending on how you look at it. And it's not just AI, right? This is true for the world of analytics as well, right? The data systems that support it. We have a set of use cases where we're saying, well, okay, it's customer-facing analytics. Like it's on the right-hand side, but it's clearly on the left-hand side, right? And so what does that mean? And I think what it means is ultimately these worlds are starting to come together. And it's no longer a one-directional flow from the operational side of the house out into the data warehouse. It's no longer enough to just have a big kind of dump of batch data. And I think that our thinking about data products has to evolve as well. You might call what we really thought of as data product as a kind of analytical data product, that thing in the data lake. But I think what you need to really stitch together all the parts of the business is something that's more universal, kind of universal data product. This sounds very conceptual, but it's actually not. A lot of companies are doing this already. It's very common, probably particularly for the folks in this audience. It can be as simple as a Kafka topic with a well-structured, thought-out schema that has some rules about how it evolves. And somebody who owns it, who's responsible for the production of this data, responsible for the structure of the data, who's going to ensure that anybody who subscribes to that feed is well-fed, and that their applications remain consistent and keep working as the business evolves, as that data feed changes, that they're kept in sync. And so I think this is the thinking around data products that I think is important, that we at Confluent has tried to build around and enable. And this has really powered a lot of our thinking about what's needed in the streaming platform. And you heard about this earlier. There's obviously a lot of terms here. But what we think of as a platform for data streaming brings together a set of different capabilities. It starts with this kind of stream of data itself. This is Kafka, or obviously there's a long list of other competitor systems, but something which is feeding that real-time stream of data that you can subscribe to, that multiple systems can feed off of, that happens in real time, but happens at the pace of each one of those subscribers. That's ultimately the start of this system. But the kind of complete platform is a little bit more than that, because you have to actually be able to connect into the different things you have and turn them into streams to hook up the rest of this ecosystem. You have to be able to reason about the flow of data across an organization. One of the nice things about batch is, well, it's like either the file got there or the file did not get there, right? It's kind of easy to reason about, like, did we deliver the file? Yes, we did. Did we process the file? Yes, we did. Or no, we didn't, but at least I know. It's kind of binary, whereas streaming is always somewhat done, right? It never quite finishes. And so you have to have a tighter view of how data is evolving, where it has gotten to, how caught up are we, and making that easy. And then finally, processing, the ability to actually react and transform and process data in real time. And you heard a little bit about Flink earlier. I think that's one of the probably most popular technologies in this streaming space. And as you get this right, these data products, they're not just a destination in themselves. They can kind of feed off of each other. You can take input streams of data, create new derived streams off of that, create very rich data streams that pull together lots of information from around the business, and that can power a lot. And this ability to do this then can feed multiple applications or destination systems. And this is not uncommon, right? Companies will often have uses for data that span online applications, a data warehouse or data lake, with reporting, AI, more real-time analytics. Many things can feed off that same data set. And building and structuring to enable that is critical to really make use of data. That's the thing that kind of breaks out of that vicious cycle of point-to-point connections. So this is ultimately what has informed our thinking at Confluent is, how can we bring together the parts of this platform? And how can we take something that was ultimately pretty painful and try and make it a lot easier, make it a lot simpler, make it easier for data to flow? And so I'll talk about one area of development here where we've been putting some effort that I think is kind of interesting and mind-expanding as it puts together these two areas. So I talked about the analytical estate and the operational estate. Operational estate being the thing that is kind of running the business, the analytical estate being my data warehouse, my data lake, all the reporting world. How do these ultimately come together? Well, it's evolved a little bit differently. I would say the use of streaming is actually very prevalent in the operational estate. When we look at a lot of companies, they now have a fair amount of data flowing in real time. They have a fair amount of applications that would hook into this and either send out streams to Kafka or receive data from Kafka in real time. And this is actually relatively well established. So if you say, hey, how should I hook up all my real-time applications and exchange data between them? You would probably get an answer something like Kafka. There's kind of a standard for that exchange. But now if it comes to the analytical estate, sure, you might feed those streams in, but it often stops there. And in the world of analytics, a lot of the applications, they really feed off of these shared tables. You have something in a data lake or a data warehouse. There are a bunch of structured tables of data that many things read out of. And one of the downsides of this world has been the degree to which all of these systems are kind of islands in and of themselves. You have a bunch of data which is locked up in some system and is only accessible by that system. So it's, hey, if I want to do anything with this data, I have to basically get support from that vendor that controls that system. And so it's been a little bit of a closed world, but this is starting to change. One of the things that has arisen across, really the larger ecosystem of data systems is, the capabilities of the cloud object stores, right? S3 has gotten better. It's gotten more reliable, it's gotten cheaper, and most importantly, it's gotten faster. And so you can rely on this as a mechanism for sharing data, and you can do that as the basis for one data system, but you can also do it across data systems. And there's a number of standards for how you could share across. One of the most prevalent is Apache Iceberg, right? This is a way of taking data that's in S3 and structuring it as a table with columns and types, everything we would expect, and getting all the advantages of kind of a column-oriented data store, right? So, so what is that useful for? Well, it's useful for having some definition that I can share across systems, that many systems can read out of or feed off of or process on top of. And this is really important in this analytics world because ultimately these tables of data are at least as important as the streams are in the operational world in terms of sharing data sets. And so having some standard that systems can share is one of the ways of escaping this data gravity. So this is something that's come around. I think it's actually a really powerful and interesting movement. Iceberg itself as a technology is not a rocket science thing. Like a lot of these interfaces, it's kind of a file format and structure for tables. A lot of the kind of deep technical details are actually in the object store itself. But nonetheless, it's the thing that kind of makes this accessible across systems. And so today when we think about, okay, how is data shared in these two worlds, you have kind of the operational state, a lot of real-time flow of data. Those streams might go off into something like Iceberg. But today, if you're trying to link these two things together, it's been typically a bit painful, right? So how do I get all the data into my lakehouse? Well, it is probably some collection of a bunch of Spark jobs that one stream at a time are trying to read the Kafka topic and parse out, different fields and update the columns. And this has all the problems that those kind of point-to-point connections had in the past, which is, hey, if anything upstream changes, there's a good chance that that stream is going to be modified. It's going to have new attributes, and that won't be reflected, or it will change somehow the definition. And so, actually getting a full copy of what's happening in the organization projected out into these tables in a way that's available it's actually a non-trivial task to undertake. And then keeping that in sync with the business is actually a big problem. And the pain here is very real. Anybody who's taken this on knows that you end up in a situation, if this is not done well, you have a ridiculous amount of code that's actually trying to untangle the data coming in. And it can break in really obvious ways where, hey, we didn't get any data load this morning. But that's actually the better case. The worst case is it breaks in some silent way where kind of bad data trickles in and somehow spreads out into pollutes all the other tables. And then it becomes the question of like, well, how do we go back to yesterday? And it's doable, but it's not an easy thing to do. And so, when we thought about this, we felt like, hey, there has to be a better way to do this. There has to be some way of actually uniting these two worlds. If we have streams as a mechanism for sharing data and we have tables as a mechanism of sharing data, maybe we could put those together more directly. To do this well, I think it actually has to cut through a couple of layers of the stack. So it has to directly start in the data layer with the stream. It has to go out into the governance. At the end of the day, this is not just about bytes. It's about the structure of data. What is the schema? What is the schema between these two areas? And it's going to involve the processing of data. How can we actually do processing in real time so data is landing in the way that we want it? Each of these three layers of the stack has to work if we want to truly unify this story. And this is actually some of what we've been undertaking at Confluent over the last year, is trying to really have a cohesive story across these. And to do that, it actually starts in the storage of the stream. And so for Confluent Cloud, we have an underlying system called Cora, which serves our cloud offering. This serves tens of thousands of Kafka instances, all off of some very powerful, scalable multi-tenant stack that runs across the three cloud providers. The underlying data store for all these streams is the object stores in the cloud. It's S3, it's the different blob stores across the cloud providers. And so to some extent, we already have the data there in object storage. When we're talking about taking it out into a data lake, you're kind of moving it from one S3 to another. And so maybe there is some way that you could do that better, that you could do that in a way that's more structured. You could take this underlying layer of object storage and actually represent it in a way that works both as a stream, but also as a table. And that's exactly what we've done. And it may sound like an impossible task, but it's actually not that complicated. The underlying representation of a stream is this kind of commit log of changes that have occurred, one after the other. The modifications to some record, the events that occurred in a business. And the structure of a table in Iceberg is actually not that different from that. It is, again, some sequence of updates, which kind of compacts into a unique view of the table at query time. And so that transformation from a stream to a more structured table is something you can actually do off the exact same data set, literally the same files. And this makes it so that you can take the data, which is actually being tiered out in Confluent, and represent it as an Iceberg table. And we call this functionality table flow, because it's like a flowing stream. It's also represented as a table. It's kind of the wave-particle duality of data. And we're doing this in a couple phases. The first phase makes available this tiered data in Iceberg. The second phase actually works bidirectionally, like the files are shared. And so you can actually consume the historical data that's in these Iceberg tables. And then finally, we're trying to open this up so that even data that didn't come through Confluent or Quora can actually be served as something which is subscribable. You can kind of make your data lake something that you can subscribe to different tables. And the reason you might want this, if you've ever heard of the idea of reverse ETL, it's like a whole category of product that is actually kind of a very simple thing. It's just getting the data back out. It's turning the arrow back around. So that's the work which is at the kind of core data layer. How can we share data between these two areas? But a lot of the pain that I talked about was not just about that. It was about the structure. If our goal is to get structured data in real time and make it available in Iceberg, we have to be able to translate the structure from the streaming world into the Iceberg world. And to do that, we've taken the schema of events that we would have in Confluent Schema Registry, and we've projected this out to Iceberg, so there's a very direct translation. And that means you can define a schema for a topic, and click a button, and it will appear in Iceberg with the exact same set of columns and the same types. That's kind of the easy case. The more complicated case is actually to support the evolution of this as well, right? The key thing about any data stream is it's representing some part of the business. And the underlying data product it contains is going to evolve. There will be new fields, there will be new structure. One of the things that's been done in the streaming world that I think is really important is not just reasoning about the schemas, like is this data correct right now, but actually giving you control of the evolution of those schemas so you can say, okay, what changes are you allowed to make in the future? Can you just break it and take away all the fields that people have built against? If you do that, then probably those applications are going to break. And so you have to be able to support that evolution as well. And if you have those two things, you can have, I think, a much more natural flow of data between these two systems, right? You can have it be the case that whatever topics you have a very direct projection. As that data product evolves, it will appear in Iceberg. You can have exactly what I was talking about, these kind of universal data products that are available both across the operational realm as real-time events, but also in the analytical realm as complete stored tables. And that's actually a really firm foundation for the basis of unifying these two things. But there's one more thing you need, which is the ability to actually process this kind of data. It's usually not the case that data comes finished. It actually needs some work as it flows. And in order to make this really easy, you need something which allows streaming to have the kind of rich capabilities you would expect out of a batch system. And this is one of the things I think Flink has done a really good job of, is taking the semantics of working with stored data and generalizing it so that you can work with that data as it evolves, as changes occur, as rows are modified, as new events arrive, so that if you ask a question, that question might be, hey, how many customers do we have in California? You don't get an answer like 42. You get an answer that evolves as the underlying data changes. That answer is itself a kind of stream or evolving table. And this is something that Flink has done for a long time. So there was nothing we needed to do to enable that in our service for Flink. But we went a little bit further, which is, hey, now we have this historical data set in Iceberg. The data in Iceberg is extremely efficient. It's broken into columns, so you can prune out the columns you don't need. There's very efficient compression of these columns. You can read it in large batches, but it's not real-time data, right? It's updated after some minutes as you collect enough data to store something in S3. And so typically users of data have had to choose. They've had to say, okay, look, I want the real-time stream. I'll get it with millisecond latency. That's great. Or I want the kind of efficiency and large historical storage of the lake world. But what we've done is actually unite these two. And so you heard a little bit about the Lambda architecture. The idea of that is it's kind of getting pushed back onto the end user. It's saying, well, you have some data over here in some historical store. You have some data in real time. Figure out how to piece those two things together. But in reality, what you want is something which does that in the infrastructure layer. And that's what we've enabled in Confluent Cloud, is the ability to actually process historical data from the Iceberg table, but transition seamlessly to the real-time stream for the newest, most up-to-date data. And so that kind of combination of batch parallel stream processing and that transition into streaming happens seamlessly in the infrastructure where it belongs. And that enables a kind of Kappa architecture or stream-oriented architecture without you really having to think about it or build a lot of the underlying primitives to make it happen. And so, of course, the point of all of this is not Iceberg. That's actually not the end destination of it in its own right. The point is to open up this data more broadly. And we do that, of course, with these streams in Confluent, but also now with a whole set of open source technologies, commercial offerings that all integrate around Iceberg as well, including Starburst or Snowflake, even systems like Athena, DuckDB, whatever it is that can plug onto Iceberg can now use this data. And I think this actually gives pretty good advantages to both sides of the house. For your lakehouse, you're now getting data in real time. You're getting the same well-defined data products that you're using across the rest of the world. The transformations are done continuously with stream processing, so you can have data land in a format that's usable. You can eliminate a lot of the painful mapping, and so you can get out of that rat's nest of one-off Spark jobs that you had and have something that does that more systematically. But this isn't just about the lakehouse. This is about opening up these data sets across the organization, making the same things available everywhere to all the different systems. And so this has a ton of advantages for the world of data streaming and all the real-time subscribers as well, because now you have effectively infinite retention essentially for free, because you were going to store this data in your lakehouse anyway. So you have access to that now as a real-time subscribable stream. And that means that if you need to go back and reprocess it or restructure it, it's right there in the same underlying processing infrastructure. And things like the compaction of this data, the maintenance of it, some of the things that might have been problematic in self-managed open source Kafka cluster, if that data got too big, are now very automatic and handled in this underlying cloud storage layer. So that's some of the work we've been doing. I think that this touches on a larger theme, which is around the relationship of streaming and of real time to the batch world. And so, if you were to ask a technologist 5 years ago, what do you think of all this streaming real time stuff? Is that important? Yeah, they would probably say, yeah, it's really interesting. We have a few use cases for that, but it's kind of a niche, right? It's something that kind of sits on the side. And we'll do a little bit of that, but of course, most of the real work is happening offline, in my data warehouse. I load the data out there, then I do the real complicated stuff. There'll be a few things that I absolutely must have quickly, and I'll suffer a lot of pain to get that working in this streaming world, but that's not the default way I'm going to do things. And so, I think that would have been a common attitude for maybe the average technologist who was aware of this space to have maybe 5 years ago. If you ask them, well, why is that? At heart, it's a little bit weird. If you think about how a business works, it's very real time, right? There's things happening all around the world all the time in these big global businesses. There's many applications that need to react or take that in. So, if the world is doing things continuously, why are the computer systems somehow on this, hourly, daily, weekly cycle? That seems almost like some legacy of the mainframe era of, when did my batch job kick off? And if you ask the same technologist, well, why? They would probably say, well, look, there's a set of inherent limitations that hold this real-time streaming stuff back. And they might have cited different things. They might have said, well, I can't get transactionally correct results. That's just not possible in real time, so that's going to limit me. Or it's not efficient or cost-effective to do things quickly or in real time, or just the ease of use is not there. It's too hard to plug together all of these layers. And the reality is they actually would have been right, I think, on almost all of these items. All of these were limitations. But where they were a little bit wrong was they weren't actually inherent limitations. There's not some theorem in computer science that says that these things cannot be solved. It was actually just limitations of the state of the art at that time. And if you look at what's happened over the last 5 years, these gaps have been filled. You can have transactional correctness through Kafka out into the stream processing layers in systems like Flink. You can have efficiency and cost effectiveness. I think you guys heard a little bit about this yesterday, but ultimately some of the largest scale, most cost efficient workloads in the world are being done in streaming and in real time now. And so it's absolutely the case that you can do this for the big stuff, for the expensive stuff, for the workloads that have to get it right and have to do it cost effectively. And the ease of use is actually getting there. I wouldn't say it's as easy as a batch data warehouse, but it's actually getting there pretty rapidly as these technologies come together, as they're available as cloud services, as the parts kind of talk to each other without a lot of manual piping to make it all work. And so this is becoming something that's just increasingly easier and easier as a way of working. And as that happens, something really interesting occurs, which is you go from a picture that looks kind of like this, where streaming is kind of a niche on the side where you're like, I'm only going to do that where I absolutely need it. And you move to a world where streaming becomes something that's actually a kind of generalization of the batch world. And that's true very much in the way these modern stream processing systems like Flink work, where that ability to run on a data set at a point in time is really just a special case of running on an evolving data set. And to change a program that does the first to the second, it's not like rewrite the code. It's like you change a configuration and run it. It's actually just translates directly over. And I think that that's also happening in the underlying storage layer, where that kind of real-time stream is now directly representable as a table of data in the way that we would have thought of kind of stored historical tables of analytical data. And so this kind of generalization of batch and streaming and kind of coming together of the two worlds, I think is something that's very much happening. And I think it's really important. I think this opens up a whole set of applications that are really critical that cut across that operational and analytical estate. I talked about the AI applications, which naturally bridge that, the kind of customer-facing analytics, but just even the basics of customer experience, like a good modern customer experience, is a lot more data-driven than it used to be. And so the ways we're using data, it's changing. And the tools and platforms that we need to make that possible are changing. And at Confluent, this is what we're trying to enable. We want to make this data streaming platform really easy to use. We want to make sure that these kind of three key interfaces, Kafka for that stream, Flink for the processing, and Iceberg for these underlying tables of stored data are universally available and really easy to put together and use. And we want to try and make this something that really connects all the parts of the organization and makes streaming a kind of easy, natural default to use with data. And so that's very much the world we're building towards. I think it enables this whole real-time ecosystem to really thrive. And we're by no means done. It's a project we're really, I think, doing with everybody else. There's a rich open source community, all the people in the audience today, all of the technologies and innovation around it. And so it's a really exciting conference to bring together some of that, to explore the analytics side of this and how you can really bring this data to life in applications and use cases. I think that's ultimately what it's all about. So thank you all for hearing me out, and enjoy the rest of the conference.